got a little over a minute, so we're just kind of still logging in and setting things up properly. Let me grab both. Well, I'll let that sit until I'm ready to use them. I'm gonna shut that down. Hit done. Okay, I think that's all good. Captions are on. I know you guys can hear me. I'm gonna go ahead. Well, I'm not gonna use my microphone today. Q&A is there. Let me share my screen. Start the broadcast. Okay. We got just a little over a minute remaining. So I guess if you have questions about anything, now's a good time to ask them before we kind of like launch to everything. And feel free to feel free to unmute yourself today. I don't intend to use my microphone. Otherwise, we'll get the party started in just shy of a minute. Go ahead. We'll be here at max level. We got a little over 30 seconds, then we get the party started. I'm a little excited. This is like my Friday. Yeah. There a question? Oh, that's here. Okay. 15 seconds. Yeah, so I'm really enjoying like the automatic attendance. So let's give it a few more seconds. But I guess we'll go ahead and get started. So yeah, I'm really enjoying like the automatic attendance that this thing does. So and I kind of changed my settings because in the past what I would do, I used to have like a waiting room, and then I would take attendance as I would let you all in, and it was effective, but it took like forever. It would eat up so much time. So now everything I've automated that process, so it logs when you guys show up, when you leave. You're right. So I am aware that if you have a question, feel free to unmute yourself or type in the chat or use a Q&A. Otherwise, let me see. As far as announcements, so today is Wednesday. So what we're going to be doing today is kind of like wrapping up our discussion on section 1.1 graphs of equations. And so we're going to take some time to go through as many homework questions together as we can. If you have questions from the homework, if you just request it, we can work on it now together. Best practice is to make use of the Ask My Instructor. That'll send me a screenshot of your specific question. Otherwise, if it doesn't have to be your question specifically or in particular, then just bring it to my attention and, we can work on it together. Otherwise, what I'm going to do is like choose questions at random from section 1.1. Okay. So let's hop over to my math lab. So I was kind of a question. Once, twice. Okay. So I was kind of going back and forth with the gentleman from the 9 a.m. And, I took a moment. I was like, well, let me think about the due dates as far as Labor Day, right? So we don't meet this Monday, but I see where instead of things we do on Monday, I pushed it back to the next day. So it's due that Wednesday. So basically a week from today. So I think this Monday is Labor Day, so we don't meet. I think the school is closed. So, we just kind of pushed everything back by one, but don't fret if you're missing like these first few assignments, because remember, there's an automatic extension built into all assignments, right? We get unlimited attempts and there's only a 5% late penalty. So even if you submit an assignment late all the way up until the end of the semester, you can still earn 95% on any assignment, including exams once those become available. So that's huge. Unlimited attempts, the system is set to take your highest score. I'm just using my imagination, but I feel like if I were the student, I would just, keep going until I got whatever score I wanted, which is essentially what you all can do. All right. Okay, so there were some good questions this morning. We're just going to see how this unfolds with this group. And what I'd like to do is, let me see, give me a random number between 1 and 20. 1. How did it do that? And all right. So I think 17 was one of the questions that students had questions about in the morning. Okay. And be aware that this this session is being recorded. It's being live streamed to my YouTube, and attendance is being recorded. Okay. So let's look at question 17. Let's see how this unfolds. So hopefully everybody is gaining full access to Pearson. All right. So we kind of talked about that. Either you purchase it directly from this through the link in Blackboard, or you use a book voucher. If you do buy a hard copy book, make sure it comes with an unused MyMathLab access code. There's no course ID. You access it through Blackboard, right? Okay. So this question asks us to find the equation for a circle with this center tangent, which means touching at one point to the y-axis. Okay. So equation of the circle. So I think we mentioned before where, it's a good idea to have a formula sheet. The standard form of the equation of the circle is x minus h quantity squared plus y minus k quantity squared equals r squared, right? So our h in this case is -3. So when we say x minus -3, right, double negative is positive, right? So it should be x plus 3. So what that means is that through process of elimination, we can already eliminate part A, because that's already the wrong form. That's not x minus h. So we can eliminate A. And then y minus k, so it should be y minus 8. I think everything else has the proper form. So then we need the radius, right? So if the center of the circle is at -3, 8, and we want it to be tangent to the y-axis, like the y-axis serves as a tangent line, that means that our radius is 3, right? And I'm just kind of speaking like without drawing it. So if the radius is 3 and we're going to do r squared, I think we eliminated A already, right? So I was going to say, what's the difference between A and B? But we eliminated A already. So then B is the only one that satisfies those conditions through a process of elimination. All right. Okay. And again, if anything is not clear, feel free to unmute yourself to get my attention. I don't think I had anybody in this group where the following happens, but just make sure that your official Morehouse student name is your username for Zoom. I had somebody in my earlier group for multiple sessions that said Zoom user. So when I went to log attendance, I didn't know who it was. All right. And I sent an announcement. So just sooner or later, in that group is going to be first come, first serve, right? If one person's like, oh, I'm the Zoom user, and they can recover points. So you don't want to be in that boat. The simple thing is make sure that your username is your student name. Okay.
Dr. Phifer?
Yes, go ahead.
Was this assignment due today?
No, it should be due.
Oh, okay.
Yeah, a week from today.
Okay, gotcha. Thanks.
Yeah. Yep. Mm-hmm. And so the rhythm that we'll have for the remainder of the semester, basically, we'll be going through one section every week, right? So this week is 1.1. Next week is 1.2. So again, we don't meet on Monday. All right. And also keep in mind that anything that I want to say live is already in my recordings on my YouTube channel. So if you go to the playlist for College Algebra 1 and pull up the all pre-recorded lectures, if you were to go ahead and watch section 1.2 as if you were in class, take notes as if you're in class, and write down your questions. If I were to do the lecture, I'm not really going to say anything different. Like I took my time to put all the details in those recordings. So that way when we have holidays and you don't really have to wait on me to get ahead. Again, all the homework and quizzes are available right now for the entire semester. Okay. So I think we got 20. So we'll go ahead and do question 20. Okay. So this question comes from section 1.1. This is question 59. Let me log into my phone so I can see what you guys see. I'm pretty sure things are working. You guys are good about, hey, professor, this isn't working or whatever, but I want to join. That is correct. Don't connect my audio, turn my video, join. Stay as a participant. And where is it? As long as the audio is not, I think we're good. Okay. All right, so again, this question number 20, this comes from section 1.1, question 59 from the back of that section. And we're asked to answer the following questions: find the center and the radius of the circle, and find the x and y intercepts of the graph of the circle. Okay. Okay, so I want to say a student had a question about this. It was either this one or another one. So something like this, we're trying to here, I think I need to write this one out because we basically have to use this factoring technique called completing the square, right? Let me just think. Give me a moment. Yeah, let me get a copy of this guy, and we're gonna hop over to Notability so we can do some handwritten notes. So we're gonna crop it there, crop it there. We can crop it. I guess there is fine. Up there. I'm gonna copy and delete. We're gonna up here. This is correct. I would like to paste. Nice. Come on. Okay. So we're gonna do a demo on completing the square. Completing the square is a factoring technique that, you know, it's I kind of want to say it's a little bit unorthodox. I know it tends to give students a hard time. So it wouldn't hurt to bone up on how to factor by completing the square, right? Okay, so we're gonna do a demo here. So the standard, let me see, the standard form of the equation of a circle takes on the form of y minus h quantity squared plus, sorry, that's not right. It's x minus h squared plus y minus k quantity squared equals r squared. Okay. Now let me think about this. Okay, so the leading coefficient is throwing me off a little bit. So what I'm going to do, first I'm going to start by getting a copy. 2x squared plus 2y squared plus 4y equal to 0. I'm just going to kind of follow what my intuition is telling me, and then if it's wrong, we'll work on the back end to correct it. First thing I want to do, I notice that everything is a multiple of 2. All right, so I'm just going to divide all the terms by 2. All right, so I'm going to say, if I say the left divided by 2 and the right divided by 2, essentially we're going to be doing this. Okay, these are going to cancel. This is going to turn this into a 2, and that's going to go to 0. Okay. So then if we do this, on the left, we're going to have x squared plus y squared plus y equals 0. Okay, let's try working with this and see what happens. So now completing the square, we basically want to say plus b over 2 squared, right? We've done the first step where we got the leading coefficient to be a 1 in either case. We're essentially doing completing the square twice. And the first thing is to get the leading coefficient to be a 1, which we've successfully done, all right? Hopefully. So then after we get that leading coefficient to be a 1, the next thing that we want to do is the completing the square step, which is we're going to do the following. We're going to say plus b over 2 quantity squared. We really only need to do it once here because the b in the first part is 0, so we really need it once here. All right, we're saying b over 2 squared like this. And so our b in this case is the coefficient of y, which is a 1. So that's going to be 1 over 2 quantity squared. I guess so. We're going to have to go with it. Plus 1 over 2 quantity squared. It does suck that it's a fraction, but we need to go with it. So now we can rewrite the first one as x minus 0 quantity squared, right? Because, you know, there's no like first degree x term, so we can write it like this. And then if we factor the next part, it looks like it's y plus, is it a half? So it's going to be y plus 1/2 squared equals a quarter, right? Because if we say y squared plus y plus a quarter, a half times a half is a quarter, a half plus a half is 1, right? So that's essentially completing the square. I noted that, I acknowledge that that's like a little bit ambiguous, but the purple part is the crucial technique of completing the square, right? And it takes practice, so it wouldn't hurt to watch a few examples on that on like YouTube or something like that. And again, if anything is not clear, I am monitoring the Q&A in the chat, and you can also unmute yourself. But once we've got it into this form, now we can we can quickly see the center and the radius, right? So the center of our circle should be 0, comma, -1/2. And the radius is 1/2. So these should be, that should be the center and the radius of the circle. So let's see. Now we could check it before we submit it. I think just in the interest of time, I am just going to go with it. I'm a little bit nervous about that leading coefficient. I don't know why, but I'm just going to go with it. Let me grab my keyboard. Come on. Okay. So we said what, 0, -1/2? Let's see if that works. Let me think about this. It should be okay. And if, again, like we say, if we get it wrong, we're going to fix it. We'll get to the bottom of where we made our mistake. We got a 0, -1/2. Okay. Let me think. Okay, I think it's the A thing that's throwing me off. So what I'm going to do, I'm going to click on View and Example, and I'm going to see what they did there. So just give me a moment. See, they got the 5, right? And we did that form. We did that. Okay, so then that was fine. So what are we missing? Yep, negative. Yeah, it did the same thing we did. -3. Yeah. Let me go back and check my work. So what we did was fine with that leading coefficient. We divided everything by 2. That was, oh, I see the mistake. I was supposed to write 2y and I wrote 1y, and that's what threw everything off. Man, I guess when you get fractions, that could be like a flag that maybe you made a mistake somewhere. I found a mistake. Luckily, we found it, rather quickly. I'll do the correction in like red, so you know that was a mistake. Okay, so right here, I wrote 1y where that should have been 2y. I had the right thing in the above line, but then when I dropped down, that's where I made my mistake. Okay, so now let's see if we can recover from there. I'll do the new part and we'll do it in orange. Okay, so our b is actually 2, so we're saying plus 2 over 2 squared. Okay, plus 2 over 2 squared. Okay, so now if we do this, that becomes a 1. All right. So then this guy here, this changes to a 1. I think this changes to 1 as well. These guys change. So that's a 1. That's a 1. I think this is what, -1? And the radius is 1. Okay, I feel better about this. Yeah, I don't know. It was catching my attention, but I didn't take the time to try to get to the root of it. I feel better about this. Let's just go with it. Yeah. So we got 0, -1, and 1 right here. 0, -1. Okay. That's better. Yeah, so again, we just made an error when we dropped down the line. We forgot to write the 2. But other than that, everything else is fine. The radius of the circle, I think we got was 1. Type an exact answer using radicals as needed. So let's just go with 1. All right. What are the x-intercepts? Okay. So our intercepts. If I weren't doing this on Pearson, I tend to like to try to find the y-intercept first. More often than not, it's easier to find the y-intercept, but not always. But I think they're asking for the x-intercept first. So all I'm going to do to find the x-intercept, I'm going to set y to 0 and solve, right? So I guess I'll do brown. So for the x-intercept, and then this is lagging a bit. It's kind of irking me. We set y to 0, so we're going to have, that's going to give us 2x squared plus 2 times 0 squared plus 4 times 0 equals 0. All right, so this goes to 0, this goes to 0. So then we have 2x squared equals 0. Divide both sides by 2. X squared equals 0. We take the square root on both sides. Now, normally when we take square root, we do plus or minus. but square root of 0 is just is 0. So plus or minus 0 in either case is 0. So then x equals 0. So it looks like the x-intercept is the origin. So more than likely the y-intercept is the same thing, but we need to confirm it as well. Let me see. Do I have any other colors? Purple. I guess we can do maroon. So we did the x-intercept. Let's go ahead and take a look at the y-intercept. Okay. So for the y-intercept, we set x to 0 and solve. So we're going to have 2 times 0 squared plus 2y squared plus 4y equal to 0. Okay. So I think this term goes to 0. So then from there, we'll have 2y squared plus 4y equal to 0. We can factor out a 2 from all terms or divide both sides by 2. We'll get y squared plus 2y equals 0. And let me see, two numbers that multiply. Oh, no. We can factor out y. All right, we can factor out y. And that leaves us with y plus 2. 0, right? So then from here, we're saying that it crosses the y-axis when y is equal to 0 or y equals negative 2. Okay. So y equals 0 or y equals negative 2. Okay. All right. So the x-intercept and ordered pair, we got the origin. So then 0, 0. Okay. And then the y-intercept I think we got was 0, negative 2. Let me check one more time. Yeah, we got 0, negative 2. All right. So 0. So one of them is the origin, and the other one is 0, negative 2. So we have that the circle crosses the x-axis once and crosses the y-axis twice. Okay. The chat, you guys look good. The Q&A looks good. Okay, so a little bit of a stumble, but it's okay. This experience is not about being perfect. It's about can you recover from the obstacles, right? You might stumble, but then it's like, oh well, then let's find an error, let's fix it. That's what a lot of life is, right? I think we did 17 already, so let's go ahead and do 18. Okay. I don't know why it's keeping us back here, but that's okay. Find the equation of a circle with the diameters whose endpoints are given here. Okay. So if these are the endpoints of the diameter, we could find the coordinates of the center by using the midpoint. All right. So the midpoint formula, how we discussed it before, was the average of our x's, comma, average of our y's. So the x coordinate, if we took the average of 2 and 5, what is that going to be? 7 over 2. So it should be either B or D. And I think that, for the y coordinate, the average of our y's is going to be 5 over 2. So that's accounted for. So then we need to find the radius, right? I feel like the best route here would be find the distance between these 2 points and then cut it in half, right? Let me see. x2 minus x1, so that's a 3, which is a 9. 9 plus 9 is 18, so square root of 18. So what is that? 9 times 2, so that's 3 times the square root of 2. Oh, so it's just going to be 18, right? So I didn't exclusively write out the distance formula, but if you use a distance formula to find the distance between these 2 points, you'll get the square root of 18. So then when we plug the square root of 18 in on the right-hand side, remember the right-hand side is squared, so then we get a result of 18, right? So I think through a process of elimination, we eliminated A and C, so we were torn between B and D, and then again, we got the square root of 18. When squared gave us 18, so then we're going to go with D. Again, we use, oh no, I am just chock full of mistakes today. Let me look at this again. Circle diameter, whose endpoint, the radius. Oh, we forgot to divide it by 2, right? So we got the square root of 18, so then it should be the first thing. Yeah, we forgot to divide it by 2. Square root of 18 over 2. Let me think about that. I mean, I don't see why it wouldn't be B. I'm just going to go with B. Yeah, we forgot to divide it by 2 because I think the square root of 18 was the diameter. So then the radius should be the square root of 18 over 2. If we squared it, though, that would be 18 over 4, which reduces down to 9 over 2. Yeah, man, I'm just like making mistakes today. All right. I think I'm just hopped up, ready to like get on my weekend. But yeah, okay, let's go to question 13. All right. So I'm glad we're kind of at least taking some time to go through these. Let's look at question 13. And also, I made a mistake there because I didn't write it out. I'm trying to do too much in my head. And so when you try to do it in your head, you tend to make more mistakes. Versus if you kind of slow down a bit, write it out, big and legible, you're less likely to make those kind of mistakes anyway. Okay, so this is question 13. This comes from section 1.1, question 45. And we're asked to test the equation for symmetry with respect to x, y, and origin. I do want to write this one out for you all so that you can see how we do a test for symmetry, right? Because I know we didn't take the time to go through that exclusively when we were working earlier. So I would like you to see that demo now. Let me zoom out a little bit. I guess that's better. Okay. That's okay. Whatever. It'll be okay. All right, so let me start by getting a copy of the original. Okay. Go like this. Copy and delete. And I'm going to hop over to Notability. And again, all these, so you can use as a reference if you like. Okay. So now, how do we do a test for symmetry, right? So I think when we talked about symmetry on Monday, we talked about y-axis symmetry. That's going to occur whenever we have x, y. We're also going to have negative x, y. Right? So the x's change when we have y-axis symmetry. It's going to be symmetric about the y-axis. So the y-axis is going to, the left-hand side is going to be a mirror image of the right, so on and so on and so on. So let me kind of mention how we do the test for symmetry, right? So just like in that image where we said whenever we have x, y, we also have negative x, y. When we're doing a test for y-axis symmetry, we change x to negative x, we simplify, and if we get back to the original, then that means we have y-axis symmetry. All right, and there's something similar for x-axis symmetry and origin symmetry, right? So let's see the y-axis symmetry. Let's see it in action. All right, back in action. Let's go orange, and this one is going to be our test for y-axis symmetry. Okay. This thing is lagging and it's irking me, and I don't know why it's lagging. Okay, so if we're going to do a test for y-axis symmetry, we change x to negative x, we simplify, and then see if we can get back to the original, right? So first we're going to replace each x with a blank set of parentheses. Okay. And then what goes into the blank parentheses? We're replacing x with negative x. So we're gonna put a negative x into the blank parentheses. So when we're doing these substitutions, the blank parentheses are crucial because without them, then we're more likely to mix up our signs and we're more likely to make a mistake, right? Okay. So if we have a negative number raised to an even power, just for a moment, think yourself, should that be positive or negative? All right. Let me say it one more time. If we have a negative number raised to an even power, should that final result be positive or negative? Hopefully, you are thinking positive, right? Even power is going to be positive. So then if we simplify this guy, we're going to have y equals 3x to the 6 plus 6x squared. Notice that indeed is the original. So do we have y-axis symmetry? We would say yes, right? So that would be a yes. So that was y-axis symmetry. The test for x-axis symmetry is similar. For x-axis, I guess we'll do green. And I think I'm gonna shrink this down just a little bit so I can use the other half of the page. It's about like there. Oh, undo. It's about like there. Okay, that's good. So now let's do a test for x-axis symmetry. I really want to restart this because it's lagging, but it's okay. So if we're going to do a test for x-axis symmetry, let me make this note. So for y-axis, we replaced x with negative x and simplify. We replaced x over here. That's fine. Replace x with negative x, right? If we're going to do a test for x-axis symmetry, we're going to replace y with negative y and then simplify, okay? So now y becomes negative y, and I think everything else stays the same. So then we try to do manipulations to see, can we get back to the original? We do algebra or whatever. I think if we multiply both sides by a negative, it's not the original. You know, there's not really anything we can do to get back to the original here. So is there x-axis symmetry? We would say no. That one would be no. Or no x-axis symmetry. And then there's one more we need to do a test for origin symmetry. I'll do this one we'll do maroon. And we're doing the test for origin symmetry. Okay. So with y-axis symmetry, we change x. With x-axis symmetry, we change y. With origin symmetry, we change both x and y. Okay. So we're going to change both of them. We're going to have negative y equals, I forgot my blank parentheses, but that's okay. Okay. And again, we're plugging in negative x. So we change both the x and the y. Now the right-hand side, we can get back to the original, but I think we get a case similar to the x-axis, to the one above. So we cannot get back to the original. So is there origin symmetry? We would say no. It's kind of a similar argument to the green part, if that makes sense. Okay. So let me make this note here. Replace x with negative x and simplify. Replace y with negative y and simplify. All right. So that's how we do a test for y-axis symmetry, x-axis symmetry, and origin symmetry. Okay. Yeah. Okay, let's go with that. So we got yes for y-axis and no for the other two. Okay. X-axis. I think we got a no for that one. Y-axis, we got a yes for that one. We got a no for that. So there is like a theorem or a corollary or something property when it comes to these tests for symmetry. If we're doing tests for symmetry and we get two of them to be yes, then you're guaranteed for all three of them to be yes. Okay. So let me say that one more time. If we're doing the test for symmetry and we get two of them to be a yes, I want to say that we're guaranteed for all three of them to be yes at that point. Okay. All right. Okay. So we got that. We're going to let that be. Let's do another random. Let's go to question number 3. Did you guys get a chance to see Deadpool and Wolverine? And that was a good time. I had so much fun when that movie first came out. Oh, it was so much fun. Hopefully you got a chance to see it. I don't want to talk more about it beyond that because if you haven't got a chance, I don't want to spoil it for you yet. I'll give you a couple of weeks. I don't know that I'm gonna talk about it after a couple of weeks, but usually I give movies 2 weeks. If you haven't seen it in 2 weeks, then I might spoil the movie for you. So, but I'm not gonna do that here. You guys are okay. I mean, the chat looks okay. I think you guys are good. So we're gonna keep plugging the chug in. We got a little over 10 minutes remaining. Determine whether the 3 points are collinear. All right. So collinear, co meaning with, and linear meaning line, with or together. So basically, it's asking, are these 3 points on the same line? There's a couple of ways we could go about this. One technique is we can find the equation of a line through 2 points and then confirm or deny whether the third point is on that line. I want to say we can use the triangle inequality. If these 3 points are on the same line, the distance between the two shorter distances should add up to the longer distance if they're on the same line. I don't necessarily want to do the distance formula like 3 times. I think I will showcase both techniques just so that you can see it. So I think I'm going to do the equation of the line first. So if we did y equals mx plus b, well, actually, I don't know that we talked about that in full detail. And I'm pretty sure that they want us to do the distance formula 3 times, which I'm avoiding. So let me just do the distance formula 3 times again. So we're using this technique called the triangle inequality, where when we find the distance between the three distances between all 3 pairs or all 3 combinations, then the 2 shorter distances, if these 3 points are on the same line, the 2 shorter distances should equal, when we add them together, the length of the longer distance. If they're not equal, then these points are not collinear. Yeah. Okay. So we're going to go ahead and do the distance formula 3 times. It is tedious, and but that's how you learn. That's how you learn all this stuff, by just slowing down and going line by line. And by the time you finish the homework, that's essentially is enough practice to where it kind of sinks in. We're going to copy and delete. And I'm going to do the distance formula 3 times. Come on. I don't know why my device is lagging. It's totally irking me. Paste. But as long as this is moving on some level, then section 1.1, question number 11 from the back of the text. Okay. So let's do the triangle inequality where we use the distance formula. And one of my professors / mentors would say, every time you use a formula, write the formula down. That constant repetition is how you memorize it, and it gets ingrained into your memory. All right. So again, every time we use a formula, the recommendation is to write it down. So the distance between 2 points, I'm just going to say P and Q for now. Or matter of fact, I'll just do it without that. But our distance between 2 points is going to be x2 minus x1 squared plus y2 minus y1 squared. We're taking the square root of all of that. Okay. So now, whenever I have multiple points like this, I personally like to automatically label them. I'll go like x1, y1, x2, y2, x3, y3. Okay. So I'll just call this the first one D1 for the first distance between the first 2 points. So we'll say -3 minus 0. So that's going to be -3 squared plus -12 minus -10 is going to be -12 plus 10. Okay. So then that's going to be what? 9 plus 4, which is the square root of 13. We're going to leave it as a square root of 13 for right now. Okay. So then the second distance, I'll use the first and the third. So we'll say 2 minus 0, which is 2 squared, plus -8 minus a -10, So that's going to be negative 8 plus 10, which is 2, or right here, negative 8 plus 10 squared. Okay. So that's going to be 4 plus 2 squared is 4. So that's going to be the square root of 8. Okay. And the third distance, we're going to use the last 2 points. So that's going to be 2 minus a negative 3. So that's 2 plus 3 squared plus negative 8 minus a negative 12. So that's negative 8 plus 12. So that's a 4, positive 4. We'll say negative 8 plus 12 with our parentheses. Okay. So 5 squared is 25 plus 4 squared is 16. Okay. 25, 35, 41. Okay. Let me see. New. Okay, so I was trying to do this without my calculator. Okay, so what I'll do, the 2 shorter ones are the top 2, because we can't break those down further. So I'm going to add them together and see if we get square root of 41. All right, so I'm going to use my calculator. I was trying to avoid the calculator, and I could if I did the equation form, but hopefully this doesn't mess us up. Let's go to here. Just trying to think, am I thinking about this properly? Yeah, let's just go with it. Okay, so let's reload and refresh. Okay. So let's do the square root of 13 plus the square root of 8. We get an answer. And I'm gonna do square root of 41 and see if we get the same thing. That's pretty close. It's not exact though. That is irking me that it's not exact. It's close, but it's not exact. Oh my goodness, that's irking me. Okay, so before I go with an answer, because you can kind of argue either way a little bit here. What I'm going to do, I want to see the way the book did it, because they may have found the equation in the line, like the first technique that I mentioned. They may have used that. So let's kind of compare before we submit our result. Let's see what the book did. Okay. Do I need to change my result? Oh, is it not giving us that option? Okay. So I'm going to view an example. I just want to see what they did. Okay, if the sum of the distance between the 2 pairs of the points is equal to the distance between the remaining pairs. Okay, I think that's what we said. Yeah, the first distance, second distance. Okay. See, yeah, and they were able to get theirs into that form. Yeah, we can't get it. I was trying to get ours in that form, in a similar form, but we cannot. Let me look at it again. Let me just kind of make sure I got my numbers proper. I'm gonna scan one more time. So -3 minus 0, that's going to be a 9. 2 minus 0 is a 2, so that's 4. That's all 4. 12 minus 8 is also 4. I think those are okay. That's a 13. That's an 8. Because that one I can break down, but I can't with the others. And I'm getting that they're off by a little bit. Oh man, I'm not even really sure. Are the 3 points collinear? Okay, so before I submit, I'm going to try another technique. I'm going to do my other one where I find the equation of the line. And then if that one's, because this is really a no because it's not exact. It's really, really close. So it's like, if they do it based on rounding, then it might be okay. But because it's not exact, I'm leaning more towards no. But let me find the equation of the line. So if I was going to do the equation of the line, we did y equals mx plus b. So our y-intercept is -10 because it was just given to us, right? So our b is -10. So then if I'm doing my y equals mx plus b, let's choose that third point. So we'll have -8 equals 2m. Minus 10. Okay. Add 10 to both sides, we get 2 equals 2m. So then m equals 1. So we got our slope and our y-intercept. So then the equation of the line through the first and the third should be x minus 10. All right. So now what we're going to do is confirm that this works for the first one and the third one, and then see if it works for the middle one. If it doesn't work for the middle one, then it's going to be hands down, we're good to go, right? Okay, so for instance, when x is 0, we get our -10. So this guy checks out. When x is 2, 2 minus 10 is indeed -8. So this guy checks out. So this is indeed the equation of the line through the first and the third. So now we need to see, is this other one on the line or not? So when x is -3, it is not. It's close, but it's not. So I'm glad we didn't try to round here, right? Because when x is -3, we get a result of -13, but they got a result of -12, right? So that means that that third point is not on the line. So these points are not collinear, which confirms these results. I was just a little bit hesitant because it was so close, and I was like, well, are they going to start rounding on me? So we tried another technique. Are they collinear? We said no. And we got it. All right. So that was an adventure. Right. We're kind of out of time. Are there any other burning questions before we go our separate ways? So let me go ahead and make a copy. I think that is correct. Come on. Okay, I think that looks good. So when this bar finishes loading, anything that you saw me writing, you'll receive a copy of it. And oh, wait a minute, there is something in the chat. Oh yeah, what's his name? Deadpool and Wolverine. Yeah, it was a lot of fun. The cameos, like I've seen it a couple of times now, and just trying to see how many Easter eggs and cameos and all the things can we find. But one content creator I was following, he's seen it 6 times. And he's like taking notes, taking notes in the middle of the movie. Everybody's dissecting. It's just fun. It's just fun. But anyway, let me see here. 3 times. Okay. Oh, okay. All right. So, yeah, I can't think of anything else. Let me see. So I think Monday is a holiday, so we're not going to meet on Monday. I made a copy of this available, so we're going to pick back up next Wednesday, and we're going to be working on section 1.2. Idealistically, you guys can watch my recording because it's the same thing I would say live. It's just in the recording. In an ideal world, you guys will watch it in advance, take notes as if you're in class, and then that way, if we get enough people to do that in advance, then maybe we can take class time to go through the homework. But if I get the sense that people have not, watched that and aren't caught up, then instead of going through the homework together, we're going to use that class to go through the lecture, right? So that's up to you. Let me see. How do I purchase the book using a book voucher? So if you're using a book voucher to gain access to My Math Lab, you have to go to the Morehouse bookstore. I think you can buy it online or just go into the bookstore, but you need to purchase a My Math Lab access code. All right, so you have to just make sure it's a My Math Lab access code, an unused My Math Lab access code. You might just go to the bookstore. Did they move the bookstore? Like, is it in a different location aside from being next to the barbershop? Did they move it? But it might be best to just go to the bookstore and say, hey, I need and let the clerk know that you need a My Math Lab access code. You're trying to use a book voucher, and they should take care of it. It's in the same place. Okay, yeah, that's what I thought. So yeah, are there any other burning questions before we go our separate ways? Going once, going twice. Forever hold your peace and rights. Okay. So if there aren't any other burning questions, I think we've done a pretty decent recap. I'll update attendance after my next class, and we're going to go ahead and end the session here and from one beautiful mind to another. Have a great weekend, gentlemen. Enjoy your holiday, and we'll meet back next Wednesday, same time, same place. Take care. Peace. I need some outro music now. I think I'm going to let the stream continue. I'm just going to mute myself and while I wait for my next group. Mr. Bradley, did you get your question answered? You still there?
I sent it to you a message. It's a link I was asking about.
A link. Were you trying to like gain access to Pearson or something?
I wanted to make sure it's the correct book before I bought it.
Where'd you get the link from?
I copied and pasted what you had in the syllabus into the bookstore,
Okay.
the Morehouse bookstore.
You sent it to my email?
I sent it to you in the chat.
Oh, in the chat. Let me see if I pull it up here. In the chat. I haven't seen it in the chat. Yeah, I don't see it. Let me check another location. Oh, okay. Okay. Oh, that's interesting. I didn't know that happened. That's good to know. Bookstore.com with access code. I mean, yeah. Oh, but you have to use a book voucher. Yeah, I was gonna say I think it might be cheaper directly from Pearson. But righty, this looks right.
Do you have the Pearson link to buy the or to rent the book? Because I couldn't find it.
Do you have to use the book voucher?
I have no idea.
You do you personally have to use like can you just buy it directly from the site or do you have to use the book voucher?
I'm not sure. I have no idea.
Okay. Boo. Loose pages. I mean, it comes with the MyMathLab access card, so I mean, you could. This should be okay. Like this looks correct.
Okay.
Yeah.
Yeah, I was trying to make sure before I got the book, and I want to make sure it's the right book so I could still access all the homework and stuff.
Yeah. The main thing is that you need is the MyMathLab access card. That's the main thing that you need.
Okay. All right, cool. All right, thank you.
Uh-huh. All right, gentlemen. So I'm gonna just mute myself and I'll be kind of chilling, waiting for my next group.
Excuse me? Professor C.
Yep. Yep.
All right, so I was emailing you as you saw. So whenever I go through Blackboard and I like press my lab and my lab sign up and all that stuff, it takes me to a page where it says like link accounts, right? And so then I guess I assume that's where you're supposed to put in your Morehouse credentials, which I do, and it never works. So eventually I just press create new account. And so I paid for the course and everything, and it has me in the college algebra online lab with Professor Phifer. But it says to confirm that I'm in the right course, it says you need the course ID.
Okay, so go. Are you at the computer now?
Yes, sir. Hold on, let me pull up the website though.
No. Go to the Morehouse portal.
Just the portal, not Blackboard.
Yeah, go to Blackboard.
I'll go to Blackboard. Okay.
Yeah. And when you log into Blackboard, instead of using the main link that's in the center, there's a link on the left-hand side that says Access Pearson. Use that link instead.
Wait, it's like, hold on. I'm in Blackboard. I see all my courses. So click on our course, right?
Yeah, click on our course.
And then I'm just looking at it says daily live structure session Zoom.
Not there. On the left-hand panel, what kind of device are you working on?
A Dell computer.
Yeah, on the left-hand panel in the burgundy toolbar, there should be something that says Access Pearson. Try that link.
All I see is course content, homepage, announcements, syllabus, online Alex lab.
Let's see if I can pull it up. So if I go to here, which class are you in? The 2 o'clock, 3 o'clock?
2 o'clock.
2 o'clock. Okay. Yeah, I don't know. They keep changing things, and so that's kind of throwing things off. If we go into Blackboard, and I kind of got to be quick because I got another class that starts in like 1 minute.
We can come back to it at the end of class too if you want.
Oh no, we can go ahead and let me see if I go to our course.
Do you think I'm gonna have to repay for the course since I guess I
Hey,
paid for it?
Say it one more time.
You think I'm gonna have to repay for the course since I paid for it, I guess, on a random created account?
No, I don't think so.
All right.
Yeah, I think you might be okay. So on the left-hand panel, you see where it says course content, homepage, announcement, syllabus. Under syllabus, not there. Hang on. Let me keep going. Where is that thing? Do you see something that you might not see? Oh, that's down here. Where is it? Course content. Okay, so maybe it's not there. Let's go. Let's try this one. And so when you use this link here where it says all assignments, that's not working?
Yeah, right. So when I click on that link, it takes me to the link your account Pearson website, and I type in my Morehouse ID and it just doesn't work. Like the Blake.Haynes with my password. And I try my email.
Hey Google, change your light color to white. What kind of error message are you getting?
Hold on, I can try entering it again.
You said you're working on a Dell?
Yes.
Make sure that you're allowing pop-ups and that you're allowing cookies.
All right.
So just try it again. If it doesn't work, try to go into the settings. Are you using like Google Chrome or something, or?
Yeah, I'm using Google Chrome. Okay, so I made an account now, so it pops up.
Does it show our course?
Yeah, the pre-calculus essentials.
Okay.
And so hold on, let me press on open my lab, see if it ask me for the course ID still.
It may have just needed a little time to like boot up or whatever.
Yeah, okay, now I'm good now. I'm good now.
Okay, yeah, it could be temperamental. So okay, yeah, no worries.
Okay, but I mean, I haven't done the homework for today, so I guess I have to catch up on that. But
Yeah, you have like a week, a little over a week. So
all right. Thank
Yeah.
you.
all right. Uh-huh. All right. So that time, let me just check my participants. Okay, so yeah, this should be my 3 o'clock group, right? Hang on. Oof. All right. So let's see. So what we're gonna the goal for today now, my energy is low, so you have to just bear with me. We're gonna have to do the best we can. The goal for today, we're gonna be wrapping up section 1.1 graphs of equations, right? So each week we focus on one section. And so on Monday, we kind of went through the lecture. And then so today the goal is to go through as many homework questions together as we can. If you have questions from the homework, now is a great time to request them. You can like type it in the chat or feel free to unmute yourself. I'm not using my microphone today. So if you wanted to do the audio, you can. Let me check the Q&A real quick. Is there anything due yet? That was at 3. Okay. I think there was like there was one assignment, but essentially it's not really. No, there's one assignment, but the late penalty is pretty much it's so small that it's practically non-existent.
All right.
Yeah. So is there anything due? How can I? Is that gonna let me do it here? I'm just gonna say no. I'm gonna say essentially no. But I think the first full set becomes available is due next Wednesday. So for instance, normally it would be due on Monday at the start of class, but this upcoming Monday is a holiday, it's Labor Day, so we're not gonna I think Morehouse is closed that day, so we're not gonna meet that day. So then I pushed everything back by a couple of days to the next section. So then the first set of assignments are due a week from today on Wednesday. Again, if you have questions from the homework, this is a good time to ask. If you do want to ask a question on the homework and you want your specific question, like with your numbers, then use the Ask My Instructor. Otherwise, you can kind of like request in the Q&A. It's kind of behaving a little bit differently. Let me see if I can. I guess I have to do it over here. So let me just do it. Mark it here. Answer live. Okay. So yeah. But yeah, feel free to like either put your question in the Q&A and I'll pull that one up or type it in the chat. Okay. So I can't think of anything else. Again, I'm a little bit foggy. I'm like sleepy. I tried to take a nap, but before class it just didn't happen. Oh, okay. So what we like to do, let me see, where's that calculator? That's not it. Is there another question? Can all the homework be found on Pearson? Yeah. Yeah. So all the homework, I put it in one location. It's all in my math lab, right? So homework, quizzes, and exams is all in the same location. So that's why that's so crucial or critical to gain access to that. Oh, here it is right here. Okay, I want you just kind of onto the side. There. Right here. Do we need this? I don't need that. I don't need this right now. And I want to go to our group. So basically with the different groups, we kind of been going through as many of the homework questions together as we can. I guess I can get rid of this too. Go back to my courses. I want to get to you all's course. Okay, this is the 3 p.m. Also, so okay, let me kind of recap the information about the lab as well. So keep in mind the lab is something totally separate, right? It's like it's really like 2 separate courses, where what we're doing is basically college algebra, like college, the stuff for college algebra. But then this course also has a lab component, and so what the lab does, it creates a custom curriculum for each of you based on like how you test, and it gives you customized content to try to strengthen areas that you would be weak in. And so that component is facilitated by my colleague Dr. Lamar. So she has her own set of like scheduling and her own separate system. So to reach her, if you go into Blackboard, on the left-hand panel, it's going to say Alex Lab. You just click there and her contact info is there. You reach out to her. And I think the lab started this week. So, I think she has multiple sessions throughout the week as well. So you might want to just, if you haven't started the lab, be sure to contact her to get that going. So all the stuff that we do together will count for 90% of your overall grade. And basically at the midterm and the final, she's going to give me a grade for each of you. I'm going to scale that so that it counts as 10% of your overall grade. Right? So her component is 10%. What we do together is 90%. Okay? So I'm glad that you guys are using the Q&A. I can get this to be a little bit more smooth. Let's see. I haven't been able to get my books yet. I'm still trying to figure out how to get them, so I'm not sure. Yeah. So when it comes to like the homework, don't stress too much about it. Just don't procrastinate it too much, right? Keep in mind that there's an automatic extension built into all assignments. So with the homework, with the first few assignments, you can still earn up to 95% even if you submit it late. It's not super strict. I really just need you guys to, like, each person to submit all their own work and try to be as prompt as possible. Again, for these first few assignments, if you're late, it's okay. Just maximize your scores. Again, we get unlimited attempts with the system set to take our highest score, and there's only a 5% late penalty, right? And I think the homework itself might count, I don't know, 20, maybe 10 or 20%. I think 10% of your overall grade, something like that. So, 5% of a 10% homework, it's like it's practically no missed points. But it's those dates are really there to just kind of keep you on track, because if you procrastinate too much, it gets real kooky. Kind of the closer we get to the midterm and the final, right? As far as reliability of technology and life stuff happening. So you don't want to procrastinate too much, but just do the best you can with these first few assignments. Get them submitted. All right, go ahead. Any questions? I think you're okay. Okay. All right. So yeah. So all the stuff we're going to be doing here, and so what you see once you gain full access to My Math Lab, these orange and blue that you see, the orange squares and blue circles, these are all the homework and quizzes for the entire semester. The only thing that you don't have access to right now are our exams, right? And so we pretty much take an exam every 3 sections. So once we finish section 1.3, then in week 5, we're going to take that week is devoted to exam 1. Once we complete section 1.6, which is chapter 1, we'll take exam 2 over chapter 1. Basically, again, every 3 sections we have an exam. Okay, so this week we're just doing section 1.1. That's fine. And so like the first assignment was basically connecting you to my the playlist that has the full lectures for these, right? Okay. 1 through 20 is good. So we're going to get a random number. We're going to start with question number 11. Question number 11. Ho. And keep in mind that this session is being live streamed to my YouTube channel, and the attendance is automatically being recorded. So it logs like when you guys show up and when you leave. So just kind of be aware of that. I acknowledge that this stuff can be kind of monotonous and boring and tedious to listen to. So I feel like a fair trade-off is, as long as you're like getting your attendance credit, I won't single you out. You see what I'm saying? Like I won't be like, so-and-so, where's your video? Turn it on, answer this question. What have you been doing? I'm not gonna hound you like that, right? Where I could and make it an oral grade or something like that, but I'm not, just because it's too much. Right? I'm trying to be easy. So because this stuff is a beast all by itself. It doesn't need me to go going hard like that. Like I can be as gentle as I can be, and it still is kind of tough, right? So it's not necessary for me to do all of that. Okay. So this question 11, right? This comes from section 1.1, question 35. Okay. And so when it comes to the stream for you all, I kind of group you with like my 2 p.m. course, and it's the same content with minor alterations. But it's like one long stream, and then I have a 9 a.m. But you can watch any of those and get what you need from it. Without sketching the graph, find the x-intercepts and the y-intercepts. Okay. Now, personally, I like to find the x-intercept first, but I think they specifically asked for the. Sorry, I personally like to find the y-intercept first because oftentimes it's easier to find than the x-intercept. But I think it's the prompt that's loaded, so we kind of need to do the x-intercept first. To find the x-intercept, what we do is set y equal to 0, right? Because y is equal to 0 everywhere on the x-axis. So if we set y to 0 and solve, it looks like we have to do factoring, right? So factoring is one of those things that we do expect you to have some level of proficiency with. We do acknowledge that like many students just are not proficient in factoring. That's why we have the thing of like the lab. That's why the lab is there to kind of help with those kind of things. If you want some like specific practice on factoring, if you log into Blackboard and open up our main folder, there's going to be, I think it's like the second or third link that says box link, all daily notes or something like that, but it says box link. You open that up and folder number 5 is going to say handouts. In that handouts folder, you're going to find 2 documents regarding factoring. One of them is a summary. It's a PDF, a 1-page document that's a summary of how to approach a factoring problem. And then the second document is a chapter devoted specifically to factoring. I got it from another text, an intermediate algebra book from almost a decade ago. But the information still holds valid to this day. So it's a chapter devoted to pretty much all the factoring scenarios that we'll come across in this course and college algebra 2, essentially. Okay, so for instance, we say that to say because in this example, we need to do factoring, right? So if we set y to 0 and solve, we're going to have like x squared minus 2x minus 15 equal to 0, right? So we basically want to see, can we factor that into the following form? All right, if I can get this to work, come on. So maybe I need to go like this. This. Okay. So we want to see, can we get it into like 2 sets of parentheses, right? If that second sign is a minus, that means the sign should be opposite. That means one number needs to be positive and the other needs to be negative, okay? We're looking for 2 numbers that multiply to give us 15 and add to give us 2. I think it's what, -5 and 3, right? -5 and 3. Notice that -5 times 3 is indeed -15. -5 plus 3 is indeed -2. So this is going to be the factored form of the original expression. Okay, and we would set this to 0. So then, if we set each one to 0 and solve, we get x equals -3 and 5. So we said -3, 5. It says type an integer or simplified fraction, use commas to separate the answers as needed. So we're saying that when we let x be -3, it makes y 0. When we let x be 5, it makes y 0. All right, let's see how do we do. Okay, so we're Gucci there. So then for the y-intercept, this is I prefer this one over the x. This one oftentimes is easier. To find the y-intercept, we set x to 0, right? If we set x to 0 here, notice the first term goes to 0, the second term goes to 0, and then all we're left with is that -15. All right, so that's how oftentimes that's how easy the y-intercept is. We got a result of -15 there. So we're saying it crosses the y-axis at -15. Okay, so that one wasn't too terribly bad. Okay, that was question 11. Let's get another random number between 1 and 20. Okay, we can go to question 10. That's fine. Definitely losing my voice. Is my student from the 4 o'clock here? I don't know. It's okay. I'm going to track him down. Without sketching the graph, find the x, y intercepts. Okay. x-intercept, if we set y to 0 and solve, we're going to have 2x equals 24. Divide both sides by 2, we get x equals 12. So we're just going to go with 12 for the x-intercept. For the y-intercept, we set x to 0 and solve. If we set x to 0, we're going to be left with 4y equals 24. Divide both sides by 4, I think we get 6 there. Okay. And again, if anything is not clear, feel free to either unmute yourself or type in the Q&A. I see we got a question in the Q&A. Or type it in the chat because I'm monitoring all of these locations. Will this meeting be recorded? I remember you saying that the past class was recorded. Yeah. So all of them are recorded. You can find them on my YouTube page. I do need to update them to put them in the right playlist. But if you go to like my channel, Beautiful Mind Phifer, and then go to live, you'll find it there as well. Right. So yeah, that's a good question. You guys are like, I wonder what these questions. Let's see. Yeah. So we answered that one. So yeah, we're good. Okay. All right. Let's keep the party going. I'm really feeling. I'm like digging. I'm digging this Q&A. I like it. Like it makes it easy. I know it's a questionnaire. You know, it's easy, and then we can kind of. It's there. You know, it saves it until we're ready to answer it. Okay. I think we did 10. So let's do another random one. Ooh, I think question 19 is a doozy. So let's go to question 19. All right. Okay. So question 19, it comes from section 1.1, question 57. Okay, I think a student from my morning class requested this one. Yeah, this one asks us to find the center and the radius of the circle. So I'm gonna take some notes on this and I'm gonna write this one all the way out. And we're gonna do a demo or a showcase of a factoring technique called completing a square. Completing a square is one of those techniques that generally gives students a hard time. So it wouldn't hurt to, you know, bone up or watch a few like YouTube clips or videos or whatever on completing how to complete the square, right? So let's go ahead and do a demo. Let me get a copy of this guy, and we'll do a demo on how to write this circle in standard form using completing the square. Right? That's essentially what we're doing. Okay. Done. Copy and delete. So we're going to hop over to Notability. Make sure I'm at the top. Come on, guy. Let me try rebooting Notability. Maybe that'll help with the lag. I think those are fine. I'm going to suppress that. And let's open up Notability again. Okay. Come on. And then it's like, I don't really want to talk anymore. My mouth is drying out. This is like, because I had a morning class, I've had a break, and then I'm just getting out of a 2 o'clock group. But it's okay. Let's paste. We're just going to power through. And expand. Okay. So now, how to find the center and the radius of a circle, we're going to use completing the square. Okay? So, the way that goes, let's see. So the first thing that we're going to do is rearrange or rewrite the terms so that we kind of group like terms together. So any term that has X, we're going to put them side by side. Any term that has Y, we're going to put side by side, so on and so on. Okay. So for instance, we got this X squared minus 6X. I'm going to leave some space and then do my Y's. So we got this plus Y squared plus 2Y. And then the 1, I'm going to move it to the, I'm going to leave some more space, and I'm going to move the 1 to the right-hand side by subtracting 1 on both sides, okay? So all I did, I kind of rearranged it so that my X terms were together, my Y terms were together, and I moved the constant to the right. So now when we go to do completing the square, the first task is we need the leading coefficient, and basically we have to do completing the square twice. We need the leading coefficient to be a 1. Now we got lucky in this example that it's already a 1, so we don't have to do any manipulation there. Okay. So now completing the square step comes in the form of we got to say plus b over 2 quantity squared and add that to both sides of the equal sign, right? So if we're just focused on the orange, our b in that case is going to be -6. So we're going to say again, we're doing plus b over 2 squared. We're going to do the same thing here, plus b over 2 squared. Okay, and same thing here, we're going to do another b over 2 squared. It's going to be similar over here. I should choose a different color or use a different label, but it's okay for now. So our b, as far as the first part, as far as the orange, is -6. So we're going to say plus -6 over 2 quantity squared. We need to do the same thing here. Okay. For the green, our b is 2. So we're going to say plus 2 over 2 quantity squared, 2 over 2 quantity squared. Okay. So now with the orange, if we simplify, I'm just going to bring the orange down. That blue part, -6 divided by 2 is -3. -3 squared is going to be a +9. Okay. The green part, I'm just bringing it down. The next blue part, 2 divided by 2 is 1. 1 squared is 1.
I'm sorry. Where did the -1 come from in the black?
Okay. So this -1 here, it came from here. When I moved it to the, I subtracted it from both sides and moved it to the right.
Oh yeah.
Yeah, you good. Okay. So now if we do the orange and blue and we factor those three, if we just focus on those three and factor them, we're looking for two numbers that multiply to 9 and add to -6. I think that's going to be x minus 3 quantity squared. For the green, y plus 1 quantity squared. I think that it looks like these guys cancel each other. Or, yeah, they basically add to 0. So on the right-hand side, it looks like we're left with 9. And instead of writing it as 9, I'm going to write it as 3 squared. Okay. So then from here, we see that the center of our circle is going to be 3 comma -1, and the radius looks like it's 3. This is my shorthand for boxing my final answer. When you see me do this bar with the double slash, it's the same as putting my final answer in a box. I'm just using it as a way to highlight my final answer. So we got 3 comma -1 is the center, and the radius was 3. Three -1. Here. Okay. 3 comma -1. Oh, not right. Let's fix that. Okay. Okay. And I think we got a radius of 3. 3. Okay. All right. Okay. So again, that one involves completing the square. Now, you know, as you kind of make your way through these assignments, you get to a question like that. If it's giving you a hard time, just kind of skip it and come back to it when like you're fresh. Finish everything else, and then come back and approach that when either you have like a tutor or some help, or when you feel fresh. Yeah. Okay. Sorry. Okay, let's try question 2. Find the distance between P and Q and the coordinates of the midpoint, right? So distance point. I think I'm going to take my notes here. Okay. So now, what I like to do is, when I have ordered pairs, if I were writing it out, which I probably should do, but I'm just not going to right now, I like to label my points as x1, y1, x2, y2. So I'm going to take my notes here. So our distance is going to be equal to, so the distance formula is the square root of, I guess I'll take some notes here. So it's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay. All right. So then if we keep going, we're going to have the square root. Now our x2, xy, our x2 is 4, so it's going to be 4 minus 4 quantity squared plus our y2 is what, 10? So it's going to be 10 minus 0 quantity squared. Okay. So then that becomes the square root. 4 minus 4 is 0, squared is 0. 10 minus 0 is 10. 10 squared is 100. So then ultimately, square root of 100 is 10. Okay. So this worked all the way out. I don't know if you want to screenshot this. This is also going to be available in the recording, so you can pull it later. I'm going to get rid of these notes and just submit a final answer of 10. Okay. And that makes sense because these are on the same vertical line and they have a distance of 10. So, I think we did it kind of like a little bit extra, but, So now if we want the coordinates of the midpoint, when we talked about this in class on Monday, we said the coordinates of the midpoint are going to be the average of our x's, comma, average of our y's, right? So the x coordinate, if we take the average of the x's, 4 plus 4 is 8, divided by 2 is going to be 8. The y coordinate, if we take the average of our y's, 0 plus 10 is 10, divided by 2 is 5, right? So then the coordinates of the midpoint should be 8, comma 5. Let's see. Oh, sorry. Not 8, but 4, right? Because 4 plus 4 is 8, divided by 2 is 4. So I just forgot to divide by 2 there. Okay. Told you, man. It's like, I don't usually do math when I'm like groggy. When I was a student at Morehouse, I would do most of my homework and studying either at work study, or I always wake up in the middle of the night, like at 2 and 3, 4 o'clock in the morning. And that's my favorite time to like study because it was, literally everybody in the city is asleep. So it's just like a ghost town. It's like, it's so quiet. It is kind of eerie and spooky, but I stayed in like the Morehouse suites, I think they're still there. And so like they had study rooms everywhere. So I would just, make sure I got my key so I don't get locked out. I had to disturb my roommates at 4 in the morning. Get some snacks and some drinks and, go to the study room and do my work. And I would try to get out of my room because if I study next to my bed, it's just going to be like constantly drawing me in. Like, come, you want to just lay down for 2 minutes. Take a power nap. Power nap turns into all night. That's the worst. I wake up, I'm like, no, it's not the whole night, So I would try to get away from my bed when I was studying. I think we got 7. Let's work on 7. So that's 2, 3, 4, 5, 6, 7 is here. Okay. Graph the equation by plotting points. Okay, so we're choosing x to be these given values of x. We'll find the corresponding y. So for instance, when x is -10, -6 minus a -10, that's a double negative. So it's going to be -6 plus 10, which is a +4. All right, then the absolute value of 4 is still 4. So when x is -10, the corresponding y should be 4. I think there's only one graph that fits that. When x is -10 and y is 4 is Looks like it's D. That's the only one that fits that one. So it seems like once we found one ordered pair and we did a process of elimination, that eliminated the other three like automatically. So we use process of elimination there. Let's look at question 1. This question comes from section 1.1. Is question 1. We're asked to plot these points. Okay. -3, 3. Right. What is that? B? Quadrant 2? Okay. What quadrant? I think we said quadrant 2. Let's see. Q&A and chat looks good. -5, 0 should be D. Which axis on the x-axis? -4 and -5, we should be in quadrant 3, which is C. Okay. And we said quadrant 3. Okay. So plotting points and identifying quadrants. Let's go to question 14. We got a little over 10 minutes, right? So we don't have that much more remaining. Go to question 14. Sorry. Test equation for symmetry with respect to the x-axis, y-axis, and the origin. Okay, let me write this one out because I know when we went through this in the lecture notes, I don't think I gave the details on how to do a test for symmetry. So let's let me give the details on how to do a test for symmetry. Okay, so I'm starting by getting a copy of the original. Copy and delete 333. That's nice. Okay. Okay, we just paste. Siri, turn the heater off. Gotta have that background noise going. I meant to turn it off a long time ago. Okay. Oh. All right, so let me see. So to do a test for symmetry, right? So we have 3 types of symmetry that we consider, and we're going to start with the test for y-axis symmetry. Okay. So suppose we want to do a test for y-axis symmetry. Okay. What we're going to do here, when we want to test for y-axis symmetry, we're going to change x to -x. So this is my shorthand for change. It's a triangle. It's called delta. It just means change. So I'll label that here. This means change. Change x to -x. And then we want to simplify. Okay. So what that means is we're going to rewrite the original, but we're going to replace all the x's. We're going to replace them with -x. So we have y equals 3x cubed plus 4x squared. So first, to the 7 of me. First, I'll replace each x with a blank set of parentheses, and then -x goes into each blank parentheses. If we have a -1 or a negative number raised to an odd power, should the final result be positive or negative? Let me say that one more time. If we have a negative number raised to an odd power, should the final result be positive or negative? Right? So if we simplify, we have a -x to the 3rd power, so we have -x times -x times -x. The final result there should be negative, right? So -3x cubed. A similar argument for that second term, so that's going to be a -4x to the 7. Is this the original? No. And I think if we try to factor out a negative, we still can't get back to the original. So because we can't do a manipulation to get back to the original, we would say there's no y-axis symmetry. So is there y-axis symmetry? We would say no. Or, no y-axis symmetry. Okay. So if that's y-axis, then let's do x-axis symmetry. Okay. Sorry. So let's change. It's similar to like y-axis symmetry. For x-axis symmetry, we're going to change y to negative y. Okay. So then if we do this, on the left-hand side, we're going to have negative y equals, and then it's going to be 3x cubed plus 4x to the 7, right? And I think it's a similar argument. There's no manipulation that we can do to get back to the original. So then, is there x-axis symmetry? We would say no. Let's go ahead and do a test for origin symmetry. We'll do purple, I guess. We'll do maroon. Let's do a test for origin symmetry. So with origin symmetry, we change both the x and the y. So change x to negative x and simplify. Change y to negative y and simplify. So if we make these changes, let's see. Okay. So we're going to have negative y equals 3x cubed plus 4x to the 7. But our x in this case is now negative x. And we simplify. Also, I think it's because I'm looking down. I know that doesn't help. I'm just ready. We only got like about a little over 5 minutes left, so we're gonna just do our best to power through. So now I think we can do some manipulations here. This negative y, I'm just gonna bring it down. Similar argument as before. If we have a negative number raised to an odd power, the result there is going to be negative. So that's going to be a negative 3x cubed. Similar for the second one, negative 4x to the 7. If we factor out a negative from the right, or if we multiply both sides by negative, then we're going to get y equals 3x cubed plus 4x to the 7, which is, I think it's the original. 3x cubed plus 4x to the 7. So then, do we have origin symmetry? We would say yes. Right? I think I'm going to shrink these down to one page. Oops. Let's undo. One more time. Come on. It's kind of getting a little bit of hard. Okay, I see what's going on. That. It keeps grabbing the image, and I don't want to grab the image. I just want the handwritten portion. Just resizing it. So I just resized it to kind of fit it on the one page instead of multiple pages. So we only got origin symmetry. We didn't get y-axis symmetry, nor did we get x-axis symmetry. In this case, we only got origin symmetry. I think we got time for one more. So x-axis symmetry, we would say no. Okay. Y-axis symmetry, we also got no there. And then origin symmetry, we got yes. Okay. Let's try one more. Generate. Question 13. I want to do a different one because this is similar to what we just did. Let's go to question 8. So that's what? 13, 12, 11, 10, 9, 8. So this comes from section 1.1, question 25. We're asked to graph the following equation by plotting points. Use these guys. Okay, so when x is -2, okay. Can I work on this while I see that? -2, 0, and 2. Okay. So when x is -2, I think we get a result of 1. So -2, 1 is like here. Okay, plot a point. -2, 1. Oh, that could be right. Let me cancel. Let's go with this. So we said -2, 1, so I'm putting a point there. When x is 0, I think we get 9. Sorry. I want to edit this one. Edit the coordinates. So I think we got 0, 9. Okay. Submit. So when x is 0, we got 9. And then when x is 2. So 2 squared is 4 times -2 is -8. So 9 minus 8 is a 1. So this needs to be 2, 1. There it is right there. I'm going to hit save. And let's check. Okay. All right, gentlemen. Are there any burning questions before we go our separate ways? Going once, going twice. Let me go ahead and make a copy of these notes that we worked on together. Let me make a copy available. Also, once you find these notes, you can also use the notes from my 9 a.m. and my 2 p.m. They go through the same content as well, and they went through different questions, right? I think all 3 groups went through a different set of questions, but I try to put all that information together. So, like, for instance, how to access the PDF notes; those are in the same location. You should be able to see the recessions from this morning and the 2 p.m. kind of back to back in the playlist. So let me check the Q&A real quick. This is the lecture and we have to sign up. Yes, right? So the lecture and the lab are 2 separate things, right? So yeah, this is the lecture. We have homework, quizzes, and exams here. That's separate. Dr. Lamar, she has something that's separate altogether. So you have to reach out to her. Her contact info you can find in Blackboard. And then once you reach her, follow her instructions. And you wanna kind of move kind of quick because the lab started this week, and I think there are still some sessions available this week. So just reach out to her, and she'll have those details. Also, I'm pretty sure somebody in the group started a group me. So just if you're not in that group me, it's a good idea to try to connect with the person that's organizing that, and it's a good idea to be in that group. Are there any other burning questions before we go our separate ways for the weekend? Keep in mind, Monday is a holiday. It's Labor Day. So we'll meet back on Wednesday of next week, same time, same place. Going once, going twice. Right, forever hold your peace and rights. Okay, so if there aren't any burning questions, we're going to go ahead and end the session here. Again, we'll meet back next Wednesday, same time, same place. And with that, from one beautiful mind to another, Have a great weekend, gentlemen. Enjoy your holiday and see you next week. Take care. Peace.
Thank you.
Uh-huh.
Thank you.
My pleasure. Okay, so I'll go ahead and update attendance and things of that nature momentarily. Oh, actually, I need to wait like 15 minutes. I gotta connect with the other student. Okay. So I'm just gonna mute myself right now.